Greetings, students. Welcome to another interesting lesson. Today, we'll be doing physics. You are watching Western STEM Academy's online channel. Western STEM Academy is an online school that focuses on science, technology, engineering, and mathematics. Now, our core focus at Western STEM Academy is to relate all your lessons to real life. So we show you the importance of why you're learning this lesson and how it will help you in everyday life. We'll be offering intense CSEC preparation as well as intense PEP preparation. So this is the first in series of our physics lessons where you can watch and prepare solely for your CSEC examinations as well as for other physics examinations and just to broaden your physics knowledge overall. So remember to like, share, and subscribe to our channel. Alright, so today we're going to be talking about physics. What do you know about physics? Think about it. When we talk about physics, what comes to mind? What do you really think physics is? I'm gonna give you a little time for you to think about what is physics. Now, physics for us at Western STEM Academy, it's really the natural science that studies matter, its motion, and behavior through space and time, and the related entities of energy and force. Physics is one of the most fundamental scientific disciplines, and its main goal is to really understand how the universe behaves. So that's what we do when we're in physics classes. We try to understand how the universe operates. It's the branch of science concerned with the nature and properties of matter and energy. It is also the subject matter that include mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. Now, there are various careers that one can pursue once they have studied physics. Now, what I want you to do, I want you to use the internet or books or any other available material that you have to research at least 5 careers in physics. Now, I know that some of you already know some you know some already. So you can go ahead and write down the ones that you know. You're going to list them as soon as you have written them. So I'm going to give you a few minutes to do so. So you can pause this video and write down 5 careers in physics. Now I know earlier we said 5 careers, but the truth is there are many careers that one can pursue once they have studied physics. Now you can become a college professor, a research physicist, an astronomer, a ballistics expert, quantitative analyst, patent agent, biophysicist, nuclear engineer, aerospace engineer, high school science teacher, science journalist, material scientist, doctor, medical technologist, amongst many other careers. So I want you to now go ahead and share with your teacher or share with your classmates or share with the person nearest to you 5 careers that you found out that somebody who studies physics can pursue. No. Why is it even important to learn physics? Why are you here watching this video? Why couldn't you be on Netflix chilling? Why couldn't you be on social media doing something else that is more engaging? Now, it's very important for us to learn physics for many reasons. What physics does, it gives us an understanding of how forces, matter, energy, time, it gives us an understanding of the correlation between all of these, so we can better able to understand how the world operates, so that we can solve critical problems. Physics is very important in everyday life, from the ability to drive a car, ride a bicycle, walk, or even take an airplane. Can you imagine if you jump right now, what happened to you? You're gonna fall back. However, an airplane which is way heavier than you is able to defy gravity and actually go on and travel to other countries. Have you ever thought about that? Very interesting. All right. Now we're going to be watching a video on the importance of physics. Why is it important to learn physics? Awesome. Thank you so much for watching that video. Now, that video showed you how relevant, how important physics is in everyday life. So from that video, I want you to do a 2 minute reflection. Identify one, what stood out for you in that video? How do you think you can contribute to the advancement of physics, which in turn will advance the society? How can you add value? I want you to write those down. Take a minute to write that down. Now, we have come to the end of the importance and the relevance of physics. So what we're going to be starting right now, we're starting the CSEC curriculum. That's the CSEC curriculum for physics, all right? So that's what we're going to be starting. Now, physics, it's a 2-year program that students usually start in grade 10, and they sit the examination at the end of grade 11. Now, there are 2 main papers that students usually sit. They'll sit a paper 2 and a paper 1. The paper 1 usually consists of 60 multiple choice questions, while the paper 2, it's consisted of structured questions. So it has structured questions, all right? So that's what it has. There is also an SBA component where students are expected to complete labs, experiments. Now, these experiments are divided into main categories. We have ORR labs, which is observing, recording, and reporting. We have labs, which are measuring and manipulating. We have AI labs, which are analysis and interpretation. And we have the big one, PD labs, planning and designing. In the next video, I'll be showing you what these 4 skills assess. What are these 4 skills about? I'm going to be showing you that in the next video. Now, these are the skills that are assessed in the SBA component. So students usually have their SBA books, and that is assessed differently as the 3rd component of physics. If for any reason you're a private candidate and you're not sitting the exam at a center like a school, there is a paper 3 that students usually do. So it's more about experiments, hands-on, all right? Now, what we want you to learn in this second part of this video, it's about the scientific method. The scientific method. When conducting research, scientists usually use the scientific method to collect measurable empirical evidence. They collect these experiments in an experiment, or they collect these information in an experiment related to a hypothesis. Now, this is often in the form of an if or then statement, right? So you're saying, if this happened, then this is going to happen. The results of these are really aimed to support or contradict a theory. So you'll have a theory, right? So there's a theory that is purported to you, right? There's a theory. Now, scientists want to test to see if they'll approve or disapprove of this statement. So they'll go ahead and use an if or then statement. I'm going to be showing you what the scientific method is about and the different processes or steps that we have in the scientific method, all right? Now, in assessing the scientific method, we start by asking a question. So you have to ask a question. There must be a problem presented to you. That's what science is about. It's about assessing problems or assessing questions to find relevant solutions. So we'll ask a question. After asking the question, we're going to be doing a background research. From this background research, the background research is basically going to find out information about this topic. So you're going deeper into find out what's going on. You're finding out information that is already known about this question, and you're putting that forward. After that, you're going to construct a hypothesis. Many persons like to say that a hypothesis is like an educated guess. That's what some persons use. Some persons don't like the use of that. But what the hypothesis is, you're purporting a particular theory based on known evidence. Now, it's important to note, students, that your hypothesis can be correct or it can be incorrect once you have tested. So you are going to test your hypothesis to see if it's true or if it's not true. And this is particularly important when you're doing your planning and designing labs. You're also going to test with an experiment. So you can't just put forth a hypothesis and not test it. So you're going to test it with an experiment. Now, when you test this with an experiment, you're going to find out if the procedure is working or if it's not working. Let's say the procedure is not working. You're going to troubleshoot the procedure by carefully checking all steps and setup. And then you'll go back, you'll backtrack a bit and test it with an experiment, and you'll go down. Let's say the experiment actually worked, the procedure worked. Guess what? You're going to analyze data and draw conclusions. So you're going to analyze what you just found out and make conclusions based on what you found. Now, you do two things after that. The results align with hypothesis, or results align partially or not at all with hypothesis. This is what you're going to do. You're going to communicate your results. You have to communicate your results once you found them. So you're going to communicate if it was successful or if it was not successful. Did it align with your results or did it not align with your results? Let us say it actually aligned with your results. Then you just communicate it, and then it can be published as something that has been tested and proven. So many times we use that term, tested and proven, but in fact, we haven't really tested anything. But this is how we make something tested and proven. But let us say that the results align partially or sometimes not at all with the hypothesis. No, that experimental data becomes background research for new or future project. So you'll ask new questions, form new hypothesis, experiment again. So you're going back to your hypothesis stage and you're going to construct a new hypothesis, because guess what, students? You realize that that didn't work. But as scientists, we're always experimenting. And this is what they use in many situations. Let us say that they're trying to create a vaccine for coronavirus. This is what they're going to be using. They're using this scientific method. So that is why you're learning about that. So they'll put forward something, a hypothesis to say that this can work, but they'll test it and realize that it probably work or it doesn't work. If it doesn't work, we really need this cure because it's affecting us in so many ways. So scientists are going to go back to the drawing board to construct a new hypothesis. So this is the basis of all scientific research, scientific experiment. This is how scientists operate. So I want you to take keen attention to this, all right? Now, in simpler terms, the scientific method, you make an observation or question, you research, you put forward the hypothesis, you experiment, you collect your data, you analyze, and you make a conclusion. So the steps are pretty much straightforward. But let's say you have a question, you're not clear on something, then please post your questions in the comment section below and they'll be addressed. All right, thank you so much. Now, it's time for your assignment. Are you excited? I am excited. Now, what I want you to do, I want you to identify a particular problem in your community or in your country, if you want to go that far, and you're going to explain how you could use the scientific method to find possible solutions to that problem. That will be graded. So I want you to post the problem and post your scientific method. And let's see how we can alleviate this problem by using the scientific method. If you want assistance in identifying a problem, please also post in the comment section and we'll be helping you. All right, this is due next class. Now, this is actually the end. We have come to the end of our first introductory lesson to physics. So this is your introduction to physics, CSEC physics. Thank you so much for watching. My name is Felicia Ricketts. I'm a physics, chemistry, biology, integrated science, and mathematics teacher. I'm also the founder of Western STEM Academy. I'm the founder and managing director of Western STEM Academy, which is an online academy. It's an online school that focuses on the development of science, technology, engineering, and mathematics. We offer classes for students from grade 1 to grade 11. We'll be posting content on this site to help students who are at our academy as well as students who are not at our academy so that they can develop and prepare for their upcoming examinations or just to get some more practice lessons so that you can advance educationally. If you have any questions, please comment below. Thank you so much. Remember to like, comment, share, subscribe. Thanks for watching. This has been really great. I appreciate the time to be with you today. Have a good day, everyone.